Evening, everyone. Guys, am I audible? Yeah, thank you. Uh, Give me a minute. We'll start with the session for today. In our last few sessions, we were discussing with how exactly these hackers are trying to crack the passwords, right? So today, let us discuss about the same password cracking technique, but in a different scenario. So let us assume that the hacker is in our network, but hacker does not have direct physical access to the target user's computer. That is, it can be an administrator or a user, right? So assuming hacker has physical access to the sorry hacker does not have physical access to the system, but hacker is in our network. So now let me take up the scenario. So let's say I have my server, and I have my admin computer, and then there is a hacker's computer. So as I said, all these systems, they all belong to the same network, right? The hacker's computer, admin's computer, and the FTP server, they all belong to the same network. Now to reach internet, this network also has a router which is connecting the systems to internet, right? So here, now our assumption is the hacker is in the same network as the victim or the target. So this admin's computer, we can treat it as the victim or the target system from which the passwords have to be stolen, right? So hacker's computer and the victim system are both in the same network, right? and hacker does not have physical access to this machine. So hacker does not have direct physical access to the machine. So we will see how actually a hacker can steal the passwords. Now, in this particular network scenario, if admin's computer has to log in to the FTP server, right? If admin has to log into the FTP server, all the communication has to pass through this particular device, right? Where all our systems are connected. So what do you say, guys? If admin's computer have to communicate with the FTP server, or maybe admin's computer has to reach internet or anything, all that connections, right? All those requests have to pass through this particular device. Is that correct? Excuse me. So what exactly is this device? What kind of a device is it where all our computers are connected together? So this particular device, it can be a switch. Any other options? So as you say, it can either be a switch or it can be a hub, right? So you have two options, either a switch or a hub, right? This device cannot be a router because we are speaking about all the systems belonging to the same network, right? So if you have a router, right, then your systems, they'll become part of different networks. So that's not a router. And as you see, I have drawn the physical links, right? So obviously they are not connected through Wi-Fi. They are connected through the physical cable itself, right? So it can either be a switch or it can be a hub, right? So what is the primary difference between these two devices, the switch and a hub? Okay, so when you speak about a hub, it is doing broadcasting, and switch only does unicast, right? So the primary difference between these two devices, hub and a switch, is in the way how they enable communication. So when we speak about a hub, whatever request that's reaching the hub, a copy will be sent to every connected device, right? So a copy will be sent to every connected device. But when you speak about a switch, it doesn't do that. So which one is better, hub or switch? So obviously switch is better compared to a hub, right? Right. So for us to understand the concept of what actually hackers are trying to do, right? Let us consider both the scenarios. We will consider the switch and also we will consider hub. So we'll first see what actually happens if there is a hub in the network, and then we will also see what happens if there is a switch, right? Now, as you already said, if it is a hub is doing a broadcast, means if administrator has to reach the FTP server, whatever request that is initiated from admin's computer, a copy of that request will be sent to all the connecting devices, right? So a copy will be sent to all the connecting devices in the network. So now when all the devices, our FTP server, our router, the hacker's computer and admin's computer, they are all receiving a copy of this request, who is going to accept and who is going to reject the request? So we are speaking about a connection which is initiated from admin's computer towards the FTP server. So this is the connection, and because there is a hub in the network, hub is going to broadcast a copy of this request to all the systems which are available. So which system is going to accept this incoming request and which is going to reject it. Okay, so here when we speak about the FTP server, because the FTP server itself is the actual destination, FTP server will accept the request, and all the other devices, right? Hacker's computer, admin computer, router, and all the other devices which are connected in the network, they are going to reject this connection. Is that correct, everyone? Because a request initiated from admin's computer is towards the FTP server. FTP server will accept the request, and all the other devices which are connected in the network, they will all reject the request. Is that correct? Right? So all the other devices will be rejecting it. So now let us concentrate on the hacker's computer. So this particular system, the hacker's computer, is receiving a copy of the request. So whatever admin's computer is sending towards the FTP server, a copy of the request is received by the hacker's computer, but because of the behavior of your operating system, right? Because of the default behavior of your operating system, it is not accepting the request. If we can change this default behavior, instead of rejecting the request, if we can change the default behavior to accept the request, will the hacker be able to see this user ID and password? Or we'll first speak about if a hacker will be able to capture the password. If the default behavior of the hacker's computer is changed to accept all the incoming traffic instead of rejecting it, hacker will be able to capture the traffic, right? Yes. So what hackers can do, they install a package called WinPcap. Hacker will install a package called WinPcap. We can consider this WinPcap as a driver for your NIC card, right? This is for your Ethernet card, right? So whatever NIC card you have, your LAN card, so it is going to behave as a driver for the NIC card. And what this WinPcap does, it tells the NIC, or it instructs your operating system to accept all incoming traffic. So generally your operating system will see what is the destination IP address, and is that destination IP address matching with my IP address or not. If it is not matching with my IP address, operating system says, sorry, I will not accept it. I am rejecting this. But once WinPcap is installed, WinPcap tells your operating system, don't be very specific about the destination IP address, whether it is matching with your IP or not. Accept it. So if this default behavior has been changed, hacker's computer will start accepting all incoming packets, irrespective of whether the hacker's computer IP address is the original destination or not. So in short, all the broadcast traffic in the network can be accepted by the hacker's computer. This behavior, where your computer starts accepting all incoming traffic, is called promiscuous mode. So promiscuous mode is where a system starts accepting all incoming traffic, irrespective of whether it is the original destination or not. Okay, is it clear, everyone? What is promiscuous mode? Okay, yeah. So now once the system is in promiscuous mode and it is accepting all incoming traffic, hacker would also need a software which can open the packet and see if there is a user ID and password in the packet or not. So what WinPCAP does, it will let you capture all the traffic. But after you capture the traffic, you should be able to see if there is some user ID and password or not. Right. So to do that, along with WinPCAP, hacker is going to install another tool called Sniffer. So the job of this Sniffer is open the packet, view the contents of it, and see if there is any user ID and password in the content. If there is a user ID and password in the content, display that information to the hacker. If there is no user ID and password, of course, there's nothing to be displayed. Right. So with the combination of WinPCAP and Sniffer, a hacker will be able to capture the traffic and also view the user IDs and passwords that are being exchanged. Okay, this particular process of capturing traffic between two systems over a network, we call it as sniffing. So sniffing is a activity where a hacker tries to capture the traffic between different systems, right? So from a source system to a destination, hacker tries to capture the traffic and see if hacker can find some user IDs and passwords. So this particular process is called as sniffing. So is everyone clear what is sniffing? Okay. So in sniffing, you again have two classifications. If your network is connected via a hub, like our example, if your network is connected via a hub, you call it as passive sniffing. If your network is connected via a hub, right, you call it as passive sniffing, right? So in passive sniffing, is a hacker doing any kind of attack? Did the hacker do some attack in passive sniffing? So hacker did not do any kind of attack. Right? Hacker has just installed two softwares. One is a WinPCAP driver and the other is a sniffer. And hacker is just trying to listen to all the traffic. Right? So hacker is not performing any kind of attack. Hacker is just trying to capture all the incoming traffic, whatever has been broadcast by the hub. Right? So in passive sniffing, there is no attack involved. But will the hacker be able to see the user IDs and passwords in passive sniffing? Yes, hacker will be able to view the user IDs and passwords in passive sniffing, but at the same time, hacker need not perform any kind of attack when hacker is performing the passive sniffing part. So is everyone clear what is passive sniffing? Okay, and passive sniffing is done on a network that is connected via a hub. But practically speaking, do we see any network using hub today? We don't see anyone using hubs, right? So every network is connected via a switch. And here, when it is a switch, your network performance will be much better, right? Your network performance would be much better compared to a switch, compared to a hub. But if you are a hacker, there are some difficulties because, as you have already said, a switch does not perform broadcast. It only does unicached. So switch is only performing unicached. So if it is only performing unicached, the packet that is sent from admin's computer to the switch, will a copy of that packet be sent to the hacker's computer? A request that is initiated from administrator's computer, will a copy of it be sent to the hacker's machine? It will not be sent, right? So as you all know, right, just to refresh, switch maintains a MAC address table where it says, okay, on port number 1, I have seen a MAC address R. Port number 2, I have seen a MAC address F. Port number 3, I see there is a MAC address A. Port number 4, there is a MAC address H. And then it just continues, right? Port number 5, I have seen some X. Port number 6, I have seen some Y. It continues there. Right? So now when request is initiated from admin's computer to the FTP server, right? Let us also check the IP address of this systems once. We'll also make a note of that. So here, so this machine, what you see is my hacker's computer. The IP address of it is 172.22.22.13. So I'll write it down here. On the hacker's computer, 172.22.22.13. So it's 113. Let us also see what's the IP address on the admin's computer. So admin's computer is 110. Now my FTP server is on 112. The router has a default IP which is 172.22.22.1. So these are all the IP addresses. So now if administrator's computer has to speak to the FTP server, this is how the packet looks like. From 172.22.22.110 to 22.112. So the source IP address is the admin's IP, which is 22.110. Destination is the FTP server, which is 112. Source MAC address is A, which is which is the admin's computer MAC address. Destination MAC address is F, which is the FTP server. Right. So this is how your request packet looks like. Now, when this packet is received by the switch knows that it is receiving this particular packet or this particular request on port number 3 from MAC address A, and it has to deliver this packet on port number 2, that is for MAC address F. So it is performing unicached, right? Now there is no copy of this being sent to hacker's computer or the router or anyone else. Now because of this unicached, Even though hacker's computer has WinPCAP and Sniffer installed, right? WinPCAP and Sniffer have been installed on the hacker's computer, but they are not really going to help the hacker because switch itself is not doing any kind of broadcast. Switch itself is not forwarding the copy of that request to the hacker's computer. So now what should a hacker do? Can a hacker try to remove the switch and connect a hub in its place? Maybe if hacker can manage to get a old hub or something. So replacing the devices would not be possible because obviously your switches and all the devices will be logged into your server room, and obviously hacker is not going to have access to it, right? So in such case, hacker will not be able to replace the device. But what hackers can do, they can try to perform some attack on the switch. Hacker can try to perform an attack on the switch. So here, hackers were trying to do some attack called MAC address flooding attack, or in short, you can call it as MAC flooding attack. Right. Now, what happens in a MAC flooding attack? Now, let's say, for example, the switch in my office, it is a 24 port switch, and it has memory resources and all to maintain 100 MAC address in the memory, right? So I have a 24 port switch, and it has the memory resources and all to maintain up to 100 MAC addresses in the MAC table, right? So as long as it is getting 100 MAC address or less than 100 MAC address, there is no problem with the switch. But in MAC flooding attack, what happens? Assuming say hacker's computer is connected on port number 4, even though there is physically only one computer, hacker would try to advertise multiple MAC addresses. Hacker will try to advertise multiple MAC addresses. Now let's say something like H1, H2, H3, so on. Like say up to H400. So you don't have 400 physical systems connected there, but hacker is just trying to advertise multiple MAC addresses as if there are some systems connected there on port number 4. Now the problem here is your MAC table can only hold up to 100 entries, and hacker is trying to advertise 400 MAC addresses. So does the switch have required resources to accept and save all this 400 MAC address? So switch does not have the required resources to save the 400 MAC address, right? So in such condition, what happens if switch does not have required resources to save 400 MAC address? What should the switch do? One option, switch has to stop working, right? So one option, the switch has to stop working, or the second option, switch has to start broadcast. The first option, switch has to completely stop. So all your network communications, everything will be disrupted. The second option, switch has to start broadcasting. So which option do you think is preferred by the switch? Does it stop working or does it go with the broadcast? So when switch faces this kind of a situation where it does not have the resources to save all the incoming MAC address and all, right? Instead of stopping all your network activities, right? Instead of stopping all the network activities, switch will actually start broadcasting the traffic, right? So switch doesn't like to stop, right? Instead of stopping, switch will start broadcasting the traffic. Now, what happens if switch starts broadcasting the traffic? Can hackers' computer capture the traffic? If switch starts broadcasting, even though it is a switch, it is behaving as a hub. So in short, it means hacker will be able to capture the traffic, right? So this is what happens in the MAC flooding attack. Hacker would try to advertise too many fake MAC addresses, even though you don't have that many physical devices connected there, right? Hacker would try to advertise too many MAC addresses, thereby forcing the switch to broadcast, right? But unfortunately, this method will not really be successful in today's network environment, and hackers are going with a different method, alternate. Vijay, when you say like when exactly a switch start broadcasting, how do you know it? You will only know it if you're sniffing the traffic and you start seeing traffic from other systems, right? So when you start seeing traffic initiated from other systems in the network on your computer, only then you will know that switch is broadcasting it. Or if you can go there to the switch and you will, you if you have physical access to the switch, you will also be able to see all the LEDs of your switch ports. They continuously start blinking. So you will be able to see like continuous rapid blinking, and it will not stop. It will just keep on blinking continuously, right? So that's a physical indication, but you can only see it if you have physical access to the device. Okay. Yeah, when you say like communications, obviously when it is a broadcast, it would become slow, right? So when the network is under broadcast, your network responses would become slow. But as I said, this MAC flooding attack will not be successful in today's network environment, and hackers are actually using a different attack method, which is called ARP poison attack. So hackers are using a different attack called ARP poison attack. So what happens in ARP poison attack? Hacker would try to create fake ARP entries. Right? Hacker tries to create fake ARP entries and try to corrupt the ARP cache on the FTP server as well as the admin's computer. Right. So for us to understand this ARP poison, what is ARP? What is ARP? Okay, ARP is address resolution protocol. Right. So where exactly do we use it? So where do we use this ARP or address resolution protocol? Do we use it in routing? ARP is used to link your IP address, which is layer 3, to a MAC address, which is layer 2. And this ARP you are using on your PC, not on your routers. Right. So ARP, you are using this on your PC primarily, right? So this is where you try to initiate the request, right? Now, for example, if you speak about these computers, let's say admin's computer wants to communicate with FTP server. What did we say? You have the source and destination IP address and source and destination MAC address. Now, when you speak about this request, source IP address, that's the IP address of the admin's computer itself. So admin's computer know it. Destination IP address, as a end user, you are asking the system to connect to so and so IP address. So destination IP address is also known. Source MAC address, that's the MAC address of admin's computer itself. So that's not an issue. It is a known entity. But how about the destination's MAC address? As an end user, when we say connect me to so and so FTP server or connect me to so and so HTTP server, are we saying connect me to so and so MAC address? So we are not giving any MAC address of the destination, right? We only give the IP address or maybe the host name of the destination. We don't give the MAC address, right? So in such condition, our computer, which is the source, has to initiate a request to the destination. But to do that, it should know what is the destination's MAC address. Our computer should know what is the MAC address of the destination computer. Only then it can initiate the request, right? So this is where ARP is used. So what your computer does, it would broadcast a request asking who has, let's say, 172.22.22.112, right? So 112 is the IP address of the FTP server. So your computer is broadcasting a request asking who has this IP address. Tell this to 172.22.22.110 on MAC address A. So your computer is also giving its own identity into the network, saying, I am 172.22.22.110. My MAC address is A. So whoever has IP address 22.112, please tell me your details. And then the other computer, right? Whoever has 112 as IP would respond saying that 172.22.22.112 is on F. So it is giving its MAC address as a response. So that's how your computer will identify what is the MAC address of the destination system, right? So only after knowing the destination computer's MAC address, it can say that this is the MAC address of the destination computer in the request packet. Okay, so this is where your ARP is used. Is it clear? Guys, are you clear where exactly we are using ARP and how ARP is known to your computers? Okay, so here what hackers are trying to do in the ARP poison attack, hacker would start broadcasting ARP responses. So hacker will create some fake ARP responses. Right. Hacker creates fake ARP response and then distribute it into the network. So what this fake ARP responses are, hacker says if you have to reach 172.22.22.112, reach via MAC address H. Send this information to admin computer, right? And then hacker would also create another fake ARP response saying to reach 172.22.22.110, reach via MAC address H and send this information to your FTP server. Right. So hacker is saying if you have to reach the FTP server IP address, so 112 is the FTP server IP. So hacker says if you have to reach the FTP server IP address, you have to reach it from MAC address H. Then to the FTP server, hacker says if you have to reach the admin's computer IP, you have to reach from MAC address H. Right. So now what happens? Admin's computer will assume that if I have to reach 112 IP, I should go to MAC address H. Now who is this MAC address H? Is it the original FTP server or is it the hacker's computer? So MAC address H is not the actual FTP server's MAC address, that is the MAC address of the hacker's computer. So now what happens? A request that is initiated from admin's computer towards the FTP server, instead of directly going to FTP, it would come to the hacker's machine. And on the hacker's computer, as we have discussed, hacker already has installed WinPcap and Sniffer. So hacker can accept the incoming packet, view the contents of it, and then hacker would forward the request to FTP server. So after capturing the incoming request from admin's computer, checking all the contents, hacker is going to forward the request to FTP server. Right. Now, according to the FTP server, right, now your FTP application is receiving a request from which IP address? The FTP application, whatever is installed on the server, it is receiving the request. From which IP address is it receiving the request? See the original source. It is receiving the request from 22.110. And FTP server says, I have to give a reply to 22.110. Right. I have to give a reply to 22.110. Good. Now, as ARP entries have been poisoned, where is this 22.110 according to the FTP server? It is on MAC address H. According to the FTP server's operating system, 22.110 IP address is on MAC address H. So where will the reply come back to? So reply from FTP server will be coming back to the hacker's computer. Hacker would accept it, see what is the response, does it contain any information, useful information, and then send the reply back to admin's computer. The response will be shared back to admin's computer, right? So in this case, what is actually happening here? The request that is supposed to be between admin computer to the FTP server, the request which is supposed to be between admin's computer and the FTP server has been hijacked from the direct connection. Instead of being a direct connection, that has been hijacked towards the hacker's computer. So request is coming from admin's computer to the hacker's computer, and that is being forwarded to server. Response is also coming back to the hacker's computer, which will be forwarded to admin's computer, right? So can I say hacker's computer is behaving like a router between admin computer and the FTP server? The hacker's computer is behaving like a router between admin computer and the FTP server, right? In fact, this communication should be a direct communication from admin computer to the FTP, right? But because hacker is successful in performing the ARP poison, all traffic is now being redirected via hacker's computer, right? Now, why all these things happened? Because our network is connected via a switch, right? Because our network is connected via a switch, hacker has performed ARP poison attack. Now, ARP poison leads to a situation called man in the middle, because now instead of the direct communication between admin and the FTP, there's a hacker's computer coming in between, right? So you call this situation as man in the middle. And because of man in the middle, what happened? Your sessions, which were supposed to be between the user computer and the server, have been hacked. So you call it as a session hijacking, right? So you call that as session hijacking. So the sessions which were supposed to be between the admin's computer and the FTP server directly are being hijacked towards the hacker's computer. So is it clear what actually happened? So because our network is connected via a switch and hacker is unable to directly sniff the traffic because switch is not performing any broadcast, right? Hacker has to perform ARP poison, which in turn leads to a series of events. ARP poison leads to man in the middle, man in the middle leads to session hijacking, right? So can we say if our network is connected via a switch, right? Sniffing is not possible unless some attack is done. So sniffing will not be possible on a switch based network unless hacker performs a attack, right? So sniffing performed on a switch connected network or a switch based network is called active sniffing, right? So sniffing performed on a switch based network or on a network where you have a switch, you call that as active sniffing. Passive sniffing is sniffing done on a network where hub is used, right? Active sniffing, sniffing done on a network where you have a switch. So is the difference clear between active and passive sniffing? Okay, yeah. So let us see how exactly a hacker does this, right? So here to perform sniffing, right, I'll be using an application called Cain and Able. I'll be using a tool called Cain and Able. Cain and Able is a free software, right? You don't need to purchase a license or something for it. It is a free software. The only requirement is when you are using Cain and Able, you will need a system which is Windows XP Service Pack 2, right? You will require a system which is Windows XP Service Pack 2, right? So you will not be able to use Cain and Able with the newer versions like say your Windows 7, Windows 8 or Windows 10, all this, right? Only Windows XP Service Pack 2 is supported for Cain and Able, right? So in Cain and Able, you have uh, an option of uh, placing your computer into Prometheus mode, right? And also capturing the traffic and viewing the content of it, right? So both options are available in Cain and Able, right? So a very simple tool, you go to configure, you click on configure. It shows you how many NIC cards are available on your system, right? Shows you like how many NIC cards are available on your system. So if you have more than one NIC card, you'll have to select which NIC card will be used for performing the sniffing activity. But if it is only one NIC card that you have, that's not going to be a problem. So enable the option start sniffer and ARP poisoning at startup. Start sniffer and ARP poisoning at startup. So that option has to be selected. Say OK. Close. You'll have to close the application and restart it. So once you close and restart the application, that ARP poisoning and sniffing will be activated. ARP poisoning and sniffing will be activated on the system. So okay. So it already has some IP addresses listed. So I'll remove all those. So you can tell the Cain and Able software, right, by clicking on the plus symbol to check for all the IP addresses and the MAC address of different systems that are in the network. So you are telling the Cain and Able application to check for all available IP addresses and MAC addresses in our system, right? So once the IP addresses and MAC addresses are captured, it shows you what all IP addresses and MAC addresses have been captured. Means these all systems are available. It is telling us these are all the list of IP addresses. These are all the list of MAC addresses which are available in our network. Then we go into the APR, ARP poison routing. So this is where the ARP entries will be poisoned. And before I do that, let me go back to my victim's computer, right? That's the admin's computer. Let me give a command ARP-A. So here you should be able to see all the available ARP entries on the system, right? So these are all the ARP entries that are available on the system. So let me copy them onto a notepad. Okay. So as you can see, for IP addresses 172.22.22.1, it has this MAC address noted. Means as of now, admin's computer know that this IP address has this particular MAC address. So in the same way, 105 has 34D6, 112 has BDFB, 113 has 72.0b. So these are all the MAC addresses available as of now. As of now, the victim's computer or the admin's computer knows that for this MAC address, sorry, for this IP address in our LAN network, this is the MAC address. And as of now, ARP poison has not yet been done. Now we'll go back to the hacker's computer and perform ARP poison. Then we will see if we can still see the same ARP entries or will ARP entries change. So in the APR or in the ARP poison routing, I'll say try to capture the traffic between 172.22.22.110, which is my admin's computer, to 22.112, which is my FTP server. So on the left hand side, I'm choosing the source. I'm saying that traffic initiated from 22.110 has to be captured towards 22.112. Say okay. So you'll have to wait for a few seconds, right, for this ARP poison to start. So once ARP poisoning start, let us go back to the victim's computer. We'll try to recheck the ARP entries. So these are the original ARP entries before ARP poison is done. Now let us check this again. ARP-A. Now, do you see uh, if the MAC address of 112 is it the same or changed? So guys, the MAC address of 22.112, which is a FTP server, is it the same or has it changed? So it has changed, right? So it has changed to which MAC address? It has changed to 720b, which is 22.113, which is nothing but your hacker computer's MAC address. So in short, now the admin's computer is assuming that it has to reach the MAC address 720b to communicate with FTP server. But in reality, the FTP server's MAC address was something else, BDFB, right? So now from this admin's computer, let us try to log in to the FTP server and check, right? We'll be able to see if whatever password we give has been captured by the hacker's computer or not, right? Has been captured in the application or not. So let me say connect to FTP on 172.22.22.112. Okay, I give the user ID cybersec, password cybersec, and it says I'm successfully logged in. I can see like what all files and folders are available, right? And then I say okay, exit. Done. So my FTP connection was successful, right? FTP connection from my admin's computer to the FTP server is successful. I'm able to successfully log in and check the contents and all. Now we'll go back to the hacker's computer. So on the hacker's machine, we'll be able to see from 172.22.22.110 to 112, a user ID and password has been captured. So whatever the username and password, that the administrator has given, right, has been captured. Right. Now we will also be able to try something else. Now let's say I'll try to take a remote desktop of 172.22.22.112. So, okay, username cybersec, password cybersec. Okay, so as you see, from the admin's computer, I have tried to connect to a remote desktop of my FTP server, right? And as you see, I am successful in getting connected to the remote desktop. And let me disconnect from the RDP. Okay, so my RDP session was successful. So now if I go back to the hacker's computer, under APR, my RDP session is registered. Now RDP, as you know, is a encrypted connection, right? So RDP uses 128-bit encryption, and we don't have to worry. All we need to do is just right click on the uh, RDP session capture and say view. Now Enable will decrypt the connection and show you the details. So you don't have to worry about what kind of encryption and what do I do and all, right? Enable will automatically decrypt the session and show you the details. So here, as you see, you are able to see the decrypted connection, but again, these all in hex format, right? And we will not be able to directly read and understand the hex. So what we can do, we will search for a specific string called key pressed, because uh, if you have observed, when we try to take a remote desktop, it is showing us the username, then we are typing the password for that username, and only after successful verification of the password we are able to connect to the RDP, right? So I'm searching for that particular key, whatever has been pressed, right? So I'm searching for the keys that were pressed for the password. So let's say find y. Okay, so as you see, when I go with the key pressed, right, it says the first key that was pressed is C, then Y, B, E, R, S, E, C. So cybersec, that was the password what we have given, right? And it is able to show us the keystrokes that we have pressed. Okay. So Canonable is able to capture the traffic, right? And is also able to decrypt that particular connection and show you the details. Mr. Bright, when you speak about Canonable, yes, it is able to capture and decrypt your HTTPS connections also. Okay. So if hacker is in the same network as a victim, right? Hacker will be able to capture the traffic, right? Hacker will be able to capture the traffic when the victim is getting connected to the target systems, or maybe is getting connected to internet, right? So is this dangerous if hacker is able to capture the traffic, right? from a victim's computer to something else, right, on the local network or somewhere on internet, can we say that it is dangerous? Yes, right. So if the hacker and victim are in the same network, right, hacker can easily try to capture the traffic like this. Okay. So the only condition here is hacker's computer and victim's computer should belong to the same network. The destination server, right, the target server can be in the same network or it can be somewhere else on internet. So that's not going to make any difference, right? That's not going to have any impact on the sniffing or the sniffer tool's performance, right? Hacker and victim should belong to the same network. That's the only thing. Is everyone clear? So not only trying to capture the passwords, right? Hackers, if you recollect, in the last sessions, we were discussing about the brute force attack and the dictionary attacks and all, right? So hackers are also able to use those brute force and dictionary attacks, right, to compromise wireless networks, right? So for that, there is a specific procedure how this wireless networks can be compromised and all, right? So that I'll be discussing in the next session, right? So we need some special hardware for it, right? As of now, I don't have access to that, right? So in the next session, I'll show you how hackers are able to capture into this wireless networks also, right? And then we will also see if hacker is not in the same network as a victim, right? What kind of attack methods hackers can do? Because as of now, our assumption is hacker is in the same network as a victim, right? So later on, we'll take up a different scenario where we assume that hacker is in a different network. Hacker is not in the same network as a victim, and then we see what sort of attacks can be done by a hacker. Okay, is that clear, everyone? So have you guys started working with your VMs? Did anyone face any difficulty setting up your VM? Okay, so I would request like please start doing that the lab practical, right? So check with the VM, right? Maybe like today you can try to do it, right? And then let me know if you are facing some issues so that I'll be able to help you in resolving it. Mr. Bright, we'll discuss about dorking. Okay. Yeah. Okay. So for today, I'll be ending the session right now. From the next session, we'll continue till we'll continue with the wireless hacking part, and then we'll also see what kind of other techniques a hacker has to use, right? If hacker is in a different location. Thank you all, and we'll meet in the next session tomorrow.